morning of day 30 of the EV conversion of the 1968 Toyota Stout for Celadary. We finally got the motor controller back in the vehicle, diagnosed some problems, and we got the wheels turning. We did have some sort of limiting. I think there's a speed limit in the motor controller. I think we need to talk to it over serial. I spoke to Gus about that this morning, and he's going to nick out this afternoon. He's got the right programming tool. Before then, I want to get as much as I can sorted out so that it's ready to roll. Let's crack into it. Let's get the grille and the bonnet in. Righto, so I think we're good to put the dash back in the cab now. Oops, guess who forgot to turn the mic on? Anyway, Gus has just arrived and we're getting into programming the motor controller over serial so that we can solve this speed limit problem we're running into. So we've just read out what all the registers are from the motor controller, and nothing exactly jumps out at us that seems to be maybe stopping it from spinning up. I'm back here by the 1969 Toyota Stout that we grabbed the tail shaft out of in a previous episode, and yeah, Gus is just writing up a little script to try and grab some data out of the motor controller while we're running it, and I thought it was a good opportunity to just nick over here and see whether I could, whether there's a seat we can pilfer out of this one that doesn't have a massive rodent hole in it. So yeah, let's jump into the cab. Well, that was easier than I thought it was going to be. It was literally just 2 bolts at the back. No gold sovereigns under here. Some pretty old wine bottle lids though. I think we'll leave the rest of that and get on back to the workshop.
Ah, Paddy Chomsky, keeping the rats out of the seat there, are you, mate? Here, let me put a new seat in.
Well, that'll be good enough for testing.
Gus and I spent ages going back and forward here trying to figure out whether we could get this motor controller to spin up properly. We hypothesized that maybe it wasn't working properly because it wasn't under load, so we thought we'd throw the wheels on and give it a test.
Look at that, tractor tires. Back on your wheels, Bert. Let's get this thing out of here. Rightio, so I am turning the main power on. Voltage there coming up, and I'm going to turn the key on. It's going to wait for 10 seconds now that 46 volts has been reached. Then the contactor is going to click in, and I'm going to make sure there's no clutch. We're in, that's first gear. We're going to see whether we roll forward. Yeah, it's only drawing 1.5 amps.
Is that with your foot right down?
Yeah. I'll take it out of gear. Yes, we are out the door. But we kind of rolled and then used the accelerator and it sort of powered itself. We're definitely still experiencing some sort of current limit thing. So we're in the same spot we were half an hour ago, and the vehicle's not really wanting to move. Oh yeah, it all works the first time, hey? Always works the first time. Oh, well, onwards and upwards. We'll contact the motor controller company and see whether they can give us some insight with the logs we've got. But I guess signing off for day 30. A bit of change of scenery. Just up here at Cellar Dairy, pulling apart the Ford 5000. Just got the radiator out of it, and the injector pump is coming off to go and be cleaned up. While I've been doing this, we've had a whole bunch of messages flying back and forward on the local EV group. I emailed the motor manufacturer, pwrcontroller.com is their website, and they've come back with a response. There is a current sensing occurring between the motor negative and the battery negative, and I think that's our problem, because I don't have the motor negative connected to the motor negative terminal. So basically I'm looking at the motor control box, and really the key mistake I think I've made is down here. So the last video we did, as I said, I was here inside the motor control box, and we'd come up with this idea that I'd made a mistake putting the motor negative onto the battery negative terminal together. And that was a mistake, and I moved those, and it changed in the way it was operating, much more to how it was meant to be operating. And I got really excited. I didn't even set the camera up, and I was like, oh my god, after all this, it works. And I rolled out the door. After all those trials where we didn't go anywhere, I didn't have the camera running, and we rolled out the door, but it was so anemic it couldn't even drive back in, and then we were stuck out there. We do have another motor controller on the way, but in the meantime, we've been trying to work out whether or not this is behaving as it should. And I took some oscilloscope readings with the help of the EV group the other night, and they were confusing enough that Gus has put his head into this a lot, and I really appreciate that, mate, because I've been, I tell you what, well over my head. We'll jump into the cab now and we'll have a look. What we're really trying to do at the moment is figure out how this motor controller is delivering power, and whether it is actually delivering on its rating, to help us understand whether or not the new motor controller that's coming is going to be appropriate. Because at the moment this one clearly isn't. It can't even get us back in the door, and I think we're pretty confident that it's running as it was designed, aren't we?
I think so, yeah. Most
I can't see that there's any tuning left to do, so we've done a fair bit of effort to try and tune things. Anyway, so we'll jump into the cab, we'll have a look, but it's pretty exciting what we're doing with the oscilloscope, but a little techie.
Sure, so we got two readings hooked up. Channel 1, which is the yellow channel, is going to be looking at the current shunt, which is a calibrated trace on the board. We don't really know what the resistance is, so exactly how this translates to amps yet, but we should see something proportional to the amount of current that's actually flowing in the motor. And channel 2 is connected to the much high voltage motor positive side, so we should be able to see the high side FETs in the motor controller switching on and off. Both of these are readings that Ollie's taken on the cathode ray scope, but with this one we can do a longer capture and have a look at the pattern of what happens when it hits the current limit, which is the real question at the moment, is whether it's bouncing off that current limit or whether it's actually sitting on the current limit correctly.
Do you want to just get a look at it free spinning before we
Sure, yeah, let's free spin first. We can just see that it's triggering right and everything else. Yep. No shortage of noise. No, I think that's okay. I've stopped capturing, so you can stop the motor for now if you want. Well, I mean, it's very noisy, but it pretty much matches the decay.
Is that speed good, or do you want to bring it up?
No, I think that's good. Just try and get it to...
So we've got on the bottom, if I remember correctly, we've got the voltage switching cleanly in and out there, and that's the current. As soon as you move it, it gets rid of the filter.
Yeah,
that's alright.
Doesn't matter too much. So I think this is the pattern you were seeing before on the Crow, only now we can see it over and over again, which is we've got two short duty cycle pulses and they're about 50 microseconds apart. So they're on the 20 kilohertz switching frequency. So effectively, we've got a very short duty cycle. It decides that the current limit has been hit, and then it just
Turns off.
for a while until it decides that we're under the current limit, and then it tries again.
Yep.
So just ignore the spikes because they're just switching noise from the FETs, I'm pretty sure. But you're charging the inductor during these short periods when the thing's actually on in between the giant spikes, and then the inductor is discharging through the motor the rest of this time, and you never get back to zero.
Because the blue line is the 0 point in that case.
Yeah, they're both aligned on this thing. So in this case, it's
Yep.
0 voltage on the motor.
Yep.
But the current is still finding
Yep.
its way through.
And it's moving up and down,
Yeah,
but it's
but
still
it's
above 0.
Pretty flat. So you got DC component
Yep.
is most of this because it doesn't go
Yep.
change, and then you've got a bit of ripple
Yep.
up and down. Is that full throttle? Do you think?
No, that was the least throttle. That was just starting off. That's like 10% throttle. Yeah. So it does it initially
Yeah.
before it starts going, oh, I'm at my limit.
And the last capture was more then.
Higher. Yeah.
Okay.
And this is what I feel in the vehicle, that it gets all the torque initially and then doesn't change as it goes up. But yeah, I don't know whether, at this point, whether we're better to actually say, do we look for another motor controller that's, I still can't exactly tell what would be the right controller to match to that motor.
I think it's time to go back to those calculations.
Yeah.
Double check everything that you've got about how much torque you need and how much torque you think this motor produces.
Yep.
Make sure there's a decent margin in there for friction and just sort of bad days, and maybe the manufacturer being a bit optimistic.
Yep.
And if that comes out all right, then you're good. And if you find a mistake in those calculations, then maybe then it's time to think about new controllers. That would be my advice. That's what I'd do in your position.